In this lecture, you'll learn about FlexGroups. FlexGroups are a new feature for ONTAP 9 that allow you to have volumes which are a much larger size than would normally be available, and they also improve the performance too. Our normal FlexVols are limited in size. Aggregates and their disks are owned by a single node, and FlexVols are contained in one aggregate, so that limits their size. FlexVols cannot span aggregates or nodes, so they're limited to the size of the aggregate they're in on the node that they are on. The maximum size of aggregates and FlexVols is controller dependent. So on a FAS 9000, for example, the maximum aggregate size is 400 terabytes and the maximum FlexVol size is 100 terabytes. So infinite volumes came out back in ONTAP 8.1.1 to overcome that size limitation of flexible volumes. And the way that they do that is that they can span multiple aggregates. So a normal FlexVol goes in one aggregate. An infinite volume can span across multiple aggregates, across multiple nodes. So that allows an infinite volume to be much larger than a FlexVol could be. With infinite volumes, the protocols that are supported are SMB version 1, NFS version 3, PNFS, and NFS version 4.1. An infinite volume is a single scalable volume that can store up to 2 billion files and up to 20 petabytes of data, so much larger than a normal flexible volume because it does span those aggregates and nodes. With infinite volumes, they use a dedicated SVM. So if you're going to use this feature, you have to create an SVM that is used specifically for the infinite volume, and there's a one-to-one relationship between that infinite volume and its SVM. When you're using infinite volumes, the NAS clients see a single junction path and namespace for the entire volume. And as you saw in the previous slide with the supported protocols, infinite volumes are for NAS only. SAN is not supported, and actually if you're using infinite volumes, you can't use SAN at all on that particular cluster. It's going to be NAS only. Now you can have other SVMs on there with normal flexible volumes in there, but you can't have SAN. With infinite volumes, that volume can be mounted as a single export for our NFS clients or share for CIFS clients, and does not require additional changes when more storage is added. That reduces the management complexity of managing numerous volumes and mount points or shares from the client side. So I touched on this in the previous lecture about queue trees as well, where having more volumes makes management more difficult because most of the things you're going to configure in ONTAP, like your snapshots, also your snap mirror, replication, etc., are managed at the volume level. So a lot of volumes can mean a lot of management. If you use an infinite volume, that's managed as a single volume, which can make the management easier. So let's have a look and see how this simplifies the namespace. First up, looking at where we're using our normal FlexVols, like we've been covering earlier in this section. So here I've got a normal SVM using normal FlexVols. It's got its root volume, and I've got several volumes which are hanging off of there to build the namespace. These volumes can be in different aggregates on different nodes throughout the cluster. So that's with FlexVols. Then let's say that we configure an infinite volume, and we could build the same directory structure here, but rather than using separate volumes, we are using separate directories inside that one infinite volume. So when we were using FlexVols, we had 1, 2, 3, 4, 5, 6 volumes to manage. Now we've just got a single volume to manage. It's got a lot of data in there, which is more than we could fit into a single aggregate, but we can do that with a single volume now by using an infinite volume. Another use for infinite volume would be if you want to have a huge flat namespace on a volume that is bigger than would be supported with a FlexVol. So you can do that. You can create an infinite volume. It's spanning multiple aggregates. It's the single volume with single directory structure there, a huge flat directory if we want to store a huge amount of data in there. We also get additional space efficiency as well because infinite volumes support thin provisioning, deduplication, and compression. So you can make it huge, spanning across multiple aggregates. You can also make it appear to be bigger than the actual underlying physical space by using thin provisioning, and you can squeeze more into there by using deduplication and compression. And they can be expanded non-disruptively if you do want to make it larger later on. Let's look at the way that infinite volumes work. So infinite volumes are made up of constituent volumes. They have got the data constituents. There's also a single namespace constituent. What that is there for is it maps directory information and file names to the file's physical data location. So you know that with the infinite volume, it's spanning across multiple aggregates. How do we know which actual aggregate a file is on? The namespace constituent takes care of that. Also, because it's a single namespace constituent and it's critical to the infinite volume working, we need to have a backup of that. That is the namespace mirror constituents. It's a backup copy of the namespace constituent. I'll show you how that looks in a diagram coming up in a second. The way that it works with the constituents is that files are automatically distributed on ingest, so as they're received by the storage system, across all the data constituents to balance the space allocation. A single file is allocated to a single data constituent. So that's a single volume and a single aggregate. It's not striped across constituents. However, it is on top of an underlying aggregate, and that underlying aggregate does have RAID configured on there. So it's striped at the aggregate level, but at the file level, it goes into a single constituent. Okay, so here's that diagram. Let's see how this works. So in the example, I have got an infinite volume that is in an SVM, which is dedicated for it. And we've configured this infinite volume to use our nodes, controller 1, controller 2, and controller 3. We've also got controller 4 in our cluster here. That can have different SVMs on there, which are using normal flexible volumes. So looking back at the infinite volume again, you can see that it's got a single namespace constituent in our example. That's on aggregate 1, owned by controller 1. We've got the namespace mirror, which is on aggregate 6, owned by controller 3. And across all three of those controllers, we have got our data constituents, which are going to be hosting the files. Then a client up in the top left here sends in a read request for a file, which is in the infinite volume. That hits controller 1. Now, when connections are coming in over the network, it's normal, whether you're using infinite volumes or normal FlexVols, that they are going to be load balanced across all of the different controllers. So when the client sent that connection in, it could have hit controller 1, controller 2, 3, or 4. It's going to be load balanced across all of them. I'm going to show you how that load balancing works when I explain it in the networking section. In this example, just so happens that the client has hit controller 1. That is where the namespace constituent is. So controller 1 will query its namespace constituent to find out where that actual file is. It learns that the file is on aggregate 3 and a data constituent in there. So it fetches it over the cluster interconnect from aggregate 3. That goes back to controller 1. And controller 1 can then send it back to the client. Now, while this is going on, you're not going to just have one client using that infinite volume. You're going to have multiple connections happening at the same time. So while that was going on, another client shown over on the right, it sends in a read request as well. And that got load balanced over the network to controller 3 in our example. Controller 3 queries the namespace constituent on controller 1 for where the file is located. It learns that information, and then in this example, it is on aggregate 6, so it gets it from there, and sends it back to the clients. So you're going to have multiple connections happening at the same time, and you can see that the namespace constituent is going to be queried each and every time. So infinite volumes have got limited performance because of that single namespace constituent. It can become a bottleneck. Metadata operations operate in a single serial CPU thread, which is going to limit performance because you've got all those concurrent connections coming in at the same time. Metadata-intensive workloads with high file counts are affected the worst by the limitation. Okay, so up to this point, I've been talking about infinite volumes, but the lecture is about FlexGroups. So you've maybe been thinking, okay, what gives? Why have I been talking about infinite volumes? Well, the reason is that infinite volumes were the first solution to the problem. They were available in ONTAP 8. FlexGroups are now an improved solution to that same problem of having large volumes. FlexGroups were introduced in ONTAP 9.1. They are supported on FAS, AFF, and ONTAP Select platforms, not supported on the cloud platforms. And the protocols that are supported are NFS version 3, SMB2, and SMB3. So the support protocols a bit different than it was for infinite volumes. Right now, as I'm recording this, NFS version 4.1 is not supported with FlexGroups yet, but SMB2 and 3 are supported, which was not supported on infinite volumes. And I talked about infinite volumes first because FlexGroups are very similar to infinite volumes. They span multiple aggregates and nodes, so our volumes can be a larger size. And NAS clients see a single junction path and namespace for the entire FlexGroup volume, the same as it worked with infinite volumes. Other similarities. A FlexGroup can be larger than the available physical storage by using thin provisioning. It supports space efficiency with thin provisioning, deduplication, and compression, and it can be expanded non-disruptively. So same as on infinite volumes. Some more similarities. FlexVol volumes are the building blocks to a NetApp FlexGroup volume. This is the equivalent to our constituents with our infinite volumes. Each FlexGroup contains several member FlexGroup volumes, just like our infinite volumes had several constituents spread across the different aggregates. Files are distributed across all member volumes to balance the space allocation. That's going to be automatically done on ingest, and a single file is allocated to a single member volume. It's not striped across them. However, those volumes are on top of underlying aggregates, which do have RAID configured on them. Okay, so those were the similarities. Let's look now at the differences between FlexGroups and infinite volumes and why FlexGroups are better. With FlexGroups, they're tested up to 400 billion files and 20 petabytes of data. With infinite volumes, that was up to 2 billion files. So a big difference there. And this is just what they've been tested up to. They can actually go larger than that. The limitation is really just depends on the hardware that your cluster is running on. There is no namespace constituent, which was the bottleneck in infinite volumes. So that's the big difference, and that's where the performance improvement comes from. Member volumes dynamically balance space and load allocation, including metadata access evenly among members. That did not happen with infinite volumes. Another difference is you can have multiple FlexGroups in the same SVM. There's not that one-to-one relationship that there was between an infinite volume and an SVM. So looking at our FlexGroup member volumes, and you see this diagram, it looks really similar to what I used for infinite volumes before, right? But the difference is we do not have the namespace constituent there. So what happens now is client over on the left sends in a read request. That happens to hit controller 1. With our network load balancing, it could have hit any of the controllers in the cluster. And controller 1 fetches that from aggregate 3 on controller 2, sends it back to the client. Then at the same time, the client over on the right sends in a read request that happens to hit controller 3. Controller 3 fetches that from aggregate 6 and sends the read back to the client. And writes are going to work in a similar way again as well. So you can see the difference is we've taken out the namespace constituent, so we don't have that single bottleneck that all the traffic is having to go through. So there is no namespace constituent. FlexGroups dynamically balance space and load allocation, including metadata access, across multiple hardware assets and CPU cores to perform at a higher performance threshold. Operations are performed concurrently across multiple member FlexVol volumes, aggregates, and nodes. So you're getting the best use of your distributed storage system. You're using all of those different distributed hardware resources. So everything is running in parallel and distributed. You get better performance that way. Better performance not just compared to infinite volumes, but compared to your normal flexible volumes as well. Now, something to mention here is that with flexible volumes, you're still going to be load balancing across those incoming network connections, and I will show you how that works in the networking section, but you're not going to get the same level of distribution that you do with FlexGroups across all the different components for your hardware in the cluster. Because of the load balancing, FlexGroups are recommended for performance, not just size. With infinite volumes, you would only use those for the size, but with FlexGroups, you get performance improvement as well. FlexGroups provide a performance gain compared to infinite volumes and FlexVols. They're recommended for the ideal use cases that you'll see on the next slide, with volumes where the volume is 20 terabytes or larger. And metadata-intensive workloads with many new concurrently written file counts achieve the biggest boost. So this is actually the opposite of what was the biggest detriment with the infinite volumes. So what were those ideal use cases? They are unstructured NAS data. Again, just like infinite volumes, our FlexGroups are NAS protocols only, no support for SAN. So a good example of unstructured NAS data, which can take up a lot of space, would be your home directories. Also for big data, for example, Hadoop, if you're using the NetApp NFS connector, for software build and test environments, electronic design automation, log file repositories, media asset or regulatory archives, file streaming workflows, and seismic or oil and gas. So we have seismic and oil and gas. That can be a huge amount of data. So FlexGroups are great for that. So those were the ideal use cases. Where is FlexGroup not such a good idea? Well, where any file takes up over 50% of the member volume size. FlexGroups get that big performance improvement because everything is so distributed. Well, if there's a single file which takes up over 50% of the member volume size, it's not so distributed now, and that's just not going to work well with FlexGroups. Also, virtualized workloads such as VMware, not recommended to use with FlexGroups. Where particular files need to be mapped to a specific FlexVol, then, or specific location, then FlexGroups obviously are not a good match for that either. Now, while I'm talking about this, mentioned earlier that on ingest, so as the files are coming in, they're going to be automatically load balanced across all of the member volumes, and those member volumes are spread across the different aggregates. So hopefully it's obvious you want those aggregates to have the same performance characteristics. You don't want one of them to be on SSDs and another one on HDDs. Okay, but so if you do have a situation where you've got particular files, particular workload, and you want that to be mapped to a particular volume or particular location in your cluster in the layout, then FlexVol would be a better choice for that rather than FlexGroups, because again, FlexGroups, it's going to be automatically distributed throughout all the members. You don't really have control of where that is going to go. And obviously, another place where you wouldn't use FlexGroup is if you require a feature that is not supported on FlexGroup. You can check the documentation on the NetApp website to see what features are and are not supported. Obviously, this is something that's going to be updated frequently. So rather than me telling you what's available right now, just check online to see what is available as you're watching this video. Okay, let's talk about how we deploy our FlexGroups. Well, I'll show you that with a lab demo. When you do deploy the FlexGroups, the way it's going to work for the layout is the default number of member FlexVol volumes in a FlexGroup volume is 8 per node. And the member volumes are created with equal size. When using automatic creation, at least 2 aggregates are required per node when using HDD. If you've only got 1 HDD aggregate per node, you can still use FlexGroups by doing manual creation. I'll show you the difference of what that means on the next slide. If you're using SSD aggregates, then 1 aggregate per node is no problem. With the automatic methods of deployment, that will work there too. Okay, so on the first 2 points there, let's work through an example. Let's say that you have got a 2-node cluster and you're going to create a flex group which is going to be size 160 terabytes. Well, you have got 2 members and there's going to be 8 volumes per node. So 2 times 8 is going to be 16. Actual member volumes are going to be created. We specified that the size of the flex group is 160 terabytes. So that's going to be 10 terabytes per member volume. Okay, let's do another example. I'm just going to double it. Let's say that for the number of nodes, let's say that rather than a 2-node cluster, we've now got a 4-node cluster. And again, we're going to create a flex group of size 160 terabytes. Well, the number of volumes per node is going to be the same. It's still 8. We don't half it because we've got double the number of nodes. We still have 8 per node. We've got 4 nodes now, which have got 8 each. So that is going to be 4 times 8 is going to be 32 rather than 16 member volumes. So we've got 32 member volumes. The size of the flex group was 160 terabytes. So now each volume is going to be 5 terabytes. So when you create the flex group, you specify the size that you want the flex group to be, and then the system is going to automatically calculate what size the member volumes will be. The way it does that is by putting 8 member volumes per node. Each member volume is going to be the same size, and it just does the division to figure out what size to make each of those volumes. Okay, last thing to tell you is the commands for deploying flex groups. I will show you how to do these with a lab demo coming up next. For now, the original command to deploy flex groups was FlexGroup deploy. Then in ONTAP 9.2, a new command became available, which is volume create auto provision as FlexGroup. And from ONTAP 9.2, if you run the FlexGroup deploy command, it will let you do it, but it will give you a warning that it's a deprecated command. You're meant to use the new volume create auto provision as FlexGroup command now. That new command has got more control when you run it because it's got more fields available that you can configure, including nodes. So you can specify the nodes that you want to be included for this flex group. The last way you can do it is with the volume create command, but without using the auto provision as flex group field. If you do that, then it allows you to manually specify the aggregates to be used. So with volume create auto provision as flex group, you can specify the nodes. You get even more granularity with volume create without saying auto provision as, and you can actually specify down to the aggregate level when you do that. And flex groups can also be deployed in the GUI. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.